Okay, so we're going to do an example. We're trying to find the surface area of the plane x plus y plus z equal to 1 in the first octant. That's the part that's bound by positive x, y, and z axes. And so I'm going to start out by drawing a picture, just like I think you should for every problem that you do, because it helps us figure out what's going on. So my plane is the function x plus y plus z equals 1. So I could rewrite that as z is 1 minus x minus y. And I'm still not totally sure what that looks like. But I can say if x equals 0, z equals 1 minus y. I'm going to have that line right there. And if y equals 0, z is 1 minus x. Like that. And then I could even say if z is 0, then 0 is 1 minus x minus y, or y is 1 minus x. Like that. All right, so this is my region of the plane that's bound in the first octant where y is positive, x is positive, and z is positive. And the way I determine this is by setting random variables equal to 0 until I had all my bounds. And I want to find this surface area. And so if you had been given this picture and had to find surface area in the past, probably what you would have done is like created a bunch of like triangles. So here's a triangle, so I could find the length of this thing. And then here's a triangle, so I could find the length of this thing. And then, oh, now I can find area. It's 1/2 base times height. We're going to do this in what I think is a slightly easier way because I'm bad at geometry. We want to find the surface area of this thing. So we need to ask ourselves, what is our f of xy? And in our formula, the surface area is on the surface F above a region R. So if we want the surface area on this plane, we know that our F is the plane. And specifically, to get in the form f of xy, it's that z equals f of xy equals 1 minus x minus y. So that's the first part we're going to need. And we can go ahead and say that we want to calculate the 1 plus fx squared plus fy squared part, while we're doing this. So df dx is minus 1. df dy is also minus 1. So my square root 1 plus fx squared plus fy squared is just square root 1 plus negative 1 squared plus negative 1 squared. So that's square root 3. Actually, I'll go ahead and do it here. Negative 1 squared plus negative 1 squared, that's square root 3. And sometimes this will be a function of x and y still, and that's okay, as long as it's a scalar. So you could have square root x squared inside. Next up, we're going to have to find the region R. And the region R is the projection of our surface down into the xy plane. So it's this thing right here. So I'm going to go ahead and plot that separately so that we can look at it. And it was bound by the line y equal 1 minus x we found previously. So it's just this triangle right here. And this is going to be a double integral, so we have to find bounds for y and x. And you should be really used to setting these up by now, but let's talk through it. I'm going to do my y bounds first. So I start at 0 as the lowest I can go on my graph, and I go up to the line y equal 1 minus x. And then the furthest left and furthest right I go and still be underneath my region is the furthest left is 0, and the furthest right is up to 1. So x can go from 0 to 1. So now my formula was to integrate over the region R, the square root fx squared plus fy squared plus 1 dA. I have all the pieces. I found square root 1 plus fx squared plus fy squared, it's root 3. And I found the bounds for my region R, so I can go ahead and put this into a formula. I'm just going to denote it SA for surface area. Is going to be the integral where I take y from 0 to 1 minus x and x from 0 to 1. So I'm integrating with respect to y and then with respect to x. And the thing that I'm integrating inside is just that 1 plus fx squared plus fy squared, which we found out was just root 3. So root 3 can come out front. It's not doing anything. And then this is just a double integral problem. I take my innermost integral with respect to y. That gives me y evaluated from 0 to 1 minus x. Dx remains. So that becomes 1 minus x minus 0. So I'm just going to leave that minus 0 out. And I'm integrating with respect to x. So that's going to give me x minus x squared over 2, evaluated from 0 to 1. So that's going to be 1 minus 1 squared is 1 over 2 minus 0 minus 0. So we just end up getting root 3 over 2 for our answer. And if you went and calculated this surface area the geometric way, I'm sure you would get the exact same answer.